We'll be taking a look at function of a function, which is commonly known as chain rule. Okay, let's take an example. Okay, so it is more like differentiation by substitution method. So let's take an example. It said if y is equal to 3x minus 1 raised to power 9. Now we can solve this by making use of binomial expansion and increase and solve the 3x minus 1 raised to power 9 by binomial expansion, then differentiate further. However, we can solve by making a substitution of u. So let us say let u be equals to 3x minus 1. If u is equals to 3x minus 1, then y will be equals to u raised to power 9. Now, we can evaluate the y du, and we can also evaluate du dx. The y du in this case will be 9u raised to power 8, and the u dx in this case will be 3. Therefore, the y dx will be equals to the y du according to the formula of chain rule multiplied by du dx. And the y du, which is 9u raised to power 8, and the u dx, which is 3. And this will give us 27u raised to power 8. Now we substitute our u back, make our substitution of u back, and we have 27. Wherever we see u, we write as 3x minus 1 raised to power 8. So this will be the y dx for the value for the expression of y. Let's take another example. Given that y is equal to 4t raised to power 3 minus 3t all raised to power 6. Now we can see that there is an expression here of 4t raised to power 3 minus 3t. Then we can say let u be equal to 4t raised to power 3 minus 3t. Therefore, our y will be equals to u raised to power 6. So we can evaluate the y du, and we can evaluate the u dt. So our dy du is 6u raised to power 5. Our du dt will give us 12t squared minus 3. Thereafter, we are looking for the derivative with respect to t, that's the y dt, will be the y du multiplied by du dt. So this will give us 6u raised to power 5 multiplied by 12t squared minus 3. Okay, now we can rewrite our u, which is 4t cubed minus 3t. That will be 6. 4t cubed minus 3t raised to power 5 with 12t squared minus 3. So this can be our answer. Let's take one more example. Now this time we will go try and do something in the trigonometric format. Let's say we are given y is equal to 3 cos 5x squared plus 2. Now remember that if we differentiate cos at, we will have minus a sine at. Okay, or rather, if we are doing respect to x, it will be cos ax, and our answer will be minus a sine ax. Now we can make our substitution of u. So u is equal to 5x squared plus 2. Then our y becomes 3 cos u. So we can evaluate the y du, and we can evaluate the u dx. So our dy du will give us minus 3 sine u, and our du dx will give us 10x. Therefore, our dy dx, according to the formula of chain rule, will be dy divided by du multiplied by du divided by dx. Therefore, our dy du, which is minus 3 sine u multiplied by 10x. So this will give us minus 30x sine u. Converting back, substituting u back, we have 30x sine 5x squared plus 2. Now let's go in terms of tan again. This should be our final example for this video. Given that y is equal to 3 tan raised to power 4 3x. Okay. Now this can be written again as 3 tan 3x all raised to power 4. Right? So now in this case, we can say our u is equals to tan 3x, and our y becomes 3 u raised to power 4. Therefore, we can evaluate the y du, and we can also evaluate the u dx. The y du in this case is 12u raised to power 3, and the u dx in this case is 3 sec square 3x. Because remember that when you want to differentiate d dx of tan ax, which you considered in our video on differentiation of a quotient, the d dx of tan ax is equal to a sec square ax. So we apply that, and in this case our a is equals to 3. Having done that, we can now evaluate our dy dx, which will be what? Dy du using chain rule multiplied by du dx, and that is dy du, which is 12 u raised to power 3, and our du dx, which is 3 sec square 3x. Now this will give us 36 u cube sec square 3x. Now let's make our substitution of u back. That is 36 and 3x cube sec square 3x, because u is equals to tan 3x. This will give us 36 tan cube of 3x and sec square 3x. In our next video, we'll be considering more examples as regarding function of a function.